right now, I would like to present to you for our subject MAT 222 Mathematical Logic and Proving Techniques. So, our group will present a title about logical connectives. So, here's our group members. First is Norin Shazwani binti Ramli. Second is Aina Safia binti Hamzah. Third is Nuairah binti Muhammad Rafi. And lastly, Nur Alia Akilah binti Muhammad Effendi. So, if you want to know more about logical connective, we continue to the next slide.
Okay, so what is logical connective? Logical connective is a symbolic logic, which is the study of some aspects and relationship of natural language using symbols. There are two main components in symbolic logic, which are statements and connectives. Statement is a declarative sentence that can be true or false, but not both. There are two types of statement, which are primitive statement and compound statement. Primitive statement is a simple statement that consists of only one subject and one predicate, while compound statement is a combination of two or more primitive statements.
5 logical connectives in this topic, which is and, or, if then, if and only if, and not. The first compound statement is P and Q, which is conjunction. P or Q, disjunction. If P, then Q, conditional. P, if and only if Q, be conditional. And not P, negation.
Next is conjunction. Conjunction is used to combine any primary statement using the word and to form a compound statement. P and Q is denoted by P, that symbol, and Q. If P is true, then P, Q is true. Otherwise, P and the symbol Q is false. Means, if one of the statement P or Q is false, the statement is false. The statement is true if both of the statement P and Q are true.
Next, we have negation. Negation is the opposite of truth values, and it is denoted by not P. If P is true, then not P is false. If P is false, then not P is true. So this is the truth value for the negation.
So next is conditional statement. Conditional statement is a compound statement of the form if P then Q, written symbolically as P then Q. P is the antecedent, which is hypothesis, and Q is the consequent, which is conclusion. So meaning here that the conclusion need to be true so that the statement is true. For example, if P is true and Q is false, then the conditional statement P then Q is false. So next is biconditional statement. The symbol used for this statement is the arrow and is often read as P if and only if Q. P if and only if Q is equivalent to P then Q and Q then P, and means that the two statements have the same truth table and truth value. The truth value for biconditional P if and only if Q satisfies the following property. If P and Q have the same truth value, then P if and only if Q is true. It is shown in the truth table below.
Okay, so next is tautology. Tautology is a statement that is always true regardless of the circumstance in mathematics. And then we have contradiction. Contradiction is assertion of a statement and its negation. This statement that can never be true, and then its equivalence to negation of tautology. Okay, lastly is contingency. Contingency is if the true value contains true and false.
So this is example 1. We have 3 primitive statements. The first one is P, Alex plays hockey. Q, Alex is busy with assignment. And R, Alex stays at home. The first statement, Alex plays hockey and he is not busy with assignment. The symbol is P and not Q. The second one, if Alex is busy with assignment, then he stays at home. The symbol will be Q, then R. The third one, statement, Alex does not play hockey if and only if he is busy with assignment. The symbol will be not P, if and only if Q. The last one, Alex is not busy with assignment or he does not stay at home. The symbol will be not Q or not R.
For the example 2, determine whether the statement is tautology, contingency or contradictions. The symbolic compound statement is P then not Q and not Q then not P. For the first column, the true value for P is 1, 1, 0, 0. The true value for Q is 1, 0, 1, 0. The third table is negation true value is always the opposite from the true value of P. So the negation statement for not P is 0, 0, 1, 1. Negation statement for Q is 0, 1, 0, 1. For the fifth column, P then not Q. The true value is 0, 1, 1, 1. The sixth table is P then not Q and not Q. The true value is 0, 1, 0, 1. For the last column, P then not Q and not Q then not P. The true value is 1, 0, 1, 1. The last columns contain both true and false, then the proposition is called a contingency.
Okay, hi, my name is Noreen Sazwani and I would like to continue for the example 3. For example 3, I will show you guys different types of question. So let's move to the first statement. P, the statement is the car is for sale, and then Q is we can afford to buy the car. So from the statement, we need to create a sentences based on the symbol given. The first symbol is P conjunction to Q. So conjunction used to use a statement for and. The statement for that symbol is the car is for sale and we can afford to buy the car. The second symbol is negation P disjunction to Q. So statement for negation is not and disjunction is or. The statement for that symbol is the car is not for sale or we can afford to buy the car. So we continue to the third symbol is Q by conditional to P. So the statement for by conditional we use if and only if. The statement for that symbol is the car is for sale if and only if we can afford to buy the car. So we continue to the fourth symbol. Fourth symbol is negation of P conjunction to Q. Here the symbol show us the false statement. So the statement for this symbol is it is false that the car is for sale and we can afford to buy the car. For the last symbol is Q implication of P. So implication refers to if and then. And the statement will be if we can afford to buy car, then the car is for sale.
Last but not least, for the conclusion, various English words and word pair express logical connective. For example, such as and, or, if, and only if, then, and so on. Second, logical connective can be used to connect more than a pair of statements. This can be referred in our example where we did earlier, where we combine two or more primitive statements to create a compound statement. A truth table is a mathematical table used in logic which sets out the truth table of the logical expression in their functional argument. Some proposition may contain all truth value of their variable as true only, which called tautology, or false only, called contradiction, or both true and false contingency.